So we are recording, and this is Mohammed, and I will be your instructor for this session of DevOps Zero to Hero on May 3rd, 2020. So just a small introduction about myself. So I'm Mohammed, currently a site reliability engineer at Apple, and I got my PhD from Institut Telecom in Paris. I did my master's in the University of Tunis Al Manar. So I'm giving this course as a co-founder of Horizon for Education, where we thought as a group that it will be really helpful for everyone to learn new things during these confinement times. So please take a look at the platform that we have, enroll at any course, and try to learn new things. Also feel free to interrupt me at any time if you have any question. I'll try to answer. If I don't have the answer right away, I will work on it and get back to you. Also, you can use the team chat functionality also to ask your questions if you don't want to talk. Now I will jump to the platform that we have, which is studentscloud.wethink.info. I think you already got the link for the course, so if you go there, I will be also sharing my screen, so it's up to you to choose either to use the platform directly or to follow with me in Teams. Okay, so the course is called DevOps Zero to Hero, and it is meant to learn many different aspects of implementing distributed applications and testing them, deploying them in the right way, and also having some good observability and management of the application itself. So what do you expect from this course is, so first you will learn how to write some simple coding with Go language. Second, we will be trying to write some tests and do some what we call TDD, or test-driven development. So test-driven development is, I believe, is one of the best ways to write code, because it allows you to kind of reduce the amount of code that you would write, and also to make sure that it is the right code. After that, we will do some REST APIs also using Golang, but I promise after that part, like Golang will be only a tool for the future, because going forward we will be doing lots of containerization. So we would work with a use case that we will implement in Go, then we will transform it to a Docker container, we will deploy it to Kubernetes, and we will apply some nice features like CI/CD. We will build a CI/CD pipeline that will allow to go from the code that you have to run the tests that we will write together, to build the Docker image and deploy to Kubernetes. And the last part that I love the most also is using a service mesh. So a service mesh is a way of managing your application. So after the deployment itself, you need some nice mechanisms to observe what's going on with your application, how you can manage the traffic going from one component to another, how to add security, how to route the traffic if you want, how to do canary and dark releases. So if you are familiar with these terms, then fine, you will get to practice them. If you are not, then you will definitely learn new things. Okay. Yeah, so as I was saying, like the objectives are, the objective is not becoming an expert in a particular thing. So I don't promise you that you will become an expert in Golang, for example, or an expert in containerizing things. But this is, you can see it as an introduction to your learning process. So you will learn like the starting point for each of these technologies, and then you can go by yourself. You have the basics, and you will be able to either start from the code that I will be sharing, or learn new things. But already you have the basics for doing these things. Okay, so I hope that everyone went through this small evaluation. I want to put together this evaluation just to in the beginning and in the end of the course. So you evaluate the progress that you did during this this course, and if you go from a zero or a newbie for the course to hero in the end, then this is kind of the success that we are learning. But definitely you will be moving the needles to the right after finishing the course. So if you didn't do that, please take some minutes and fill in the survey here. It's gonna take 1 minute for you to do it. So I'm going to the next slide here, where we give kind of a description why I wanted to introduce Go for people, why I didn't use Java or any other language. Like the first easy answer is that I love this language. So I love the language because it is really easy to grasp, and it is pretty efficient. Like in terms of writing your code, you can really go from not knowing the language at all to being very good at writing code. This is like the first reason. The second reason is the efficiency of this language. So basically, I will not like take so much time to explain the advantages of the language itself, because its usage tells a lot about it and doesn't need me to kind of to do any advertisement to it. Just the information is this language is used by Google in like one of the biggest projects after Linux project, which is Kubernetes. So Kubernetes is written totally in Go. Docker is written in Go. Cloud Foundry, same. Like Cloud Foundry was written in a different language, and then it was kind of transformed because they knew the efficiency of this language. So why like few reasons, like technical reasons, why this language is being used by the community in general. First, like people learn it really fast because like the spec of the language is really small, like compared to other languages. Like other languages, their specifications is like hundreds and hundreds of pages. For Go, it is about like the last time I checked, it was about 51 pages. So like the spec of all the language is 51 pages. One of the huge improvements that Go is doing is in the concurrency management. So generally, other languages use like Java, for example, they use threads to do parallel programming. That using thread is still good, but it doesn't scale very much compared to Go. Go is using what we call Go routines, which are like many, you can see it as many Go routines can run in a single thread. So it is kind of a huge improvement to your runtime. And these Go routines they are used basically for the concurrency, and they use some mechanisms called channels to communicate. One more thing that I like about Go is that you don't really need a virtual machine to interpret or to run your code. For example, like Java, like the minimum thing that you need is the JVM. But with Go, we don't really need a JVM to run your code. All what you need is, after writing your code, you will just compile it to a small binary. In this binary, you can throw it anywhere and it will run as it is, because it will come with all its dependencies. It is self-contained thing. So it is, you build the binary, throw it in a Raspberry Pi, it will work. Throwing it in a Mac or in a laptop, in a virtual machine, in anywhere, it will just work. Which is, for me, it is a huge advantage. And also it has the advantage of garbage collection. It is not like C, where you need to manage the memory by yourself, but Go comes with an efficient garbage collector. So in the platform, I added this link. If you are still not convinced that Go is a good programming language to learn, there is this blog post, and also there is this this nice video that you can watch offline. All right, let's move. Okay, so as any other language, Go has its hello world example, and a nice feature that Go comes with is this what we call the playground. So if you want to write any kind of temporary code, just go to the playground, try and write some code, make it fail, make it succeed, and you don't need to install anything. This is similar to this to this small snippet of code here that I have here. So this is I try to integrate the playground here in this this thing. So this code will basically kind of print hello playground here, so we can modify it, and there is this this small button for running the code. So if we just hit it, you will see that the execution is happening here, and you can you can modify the code here and run it, and you will see that that is implemented everything. So let's try to understand what is this code, what is it doing. So many of you are probably familiar with using packages for the code. So any code written in Go, it is organized as different packages, and it is somehow similar to other languages that you need a main package that has a main function to start the program. So here we have the package main, and we have a function called main that doesn't accept any arguments, and it is somehow doing some printing. So then in the line 3, we are using this import directive. So import is basically used to reuse other code, or to include other libraries that are implemented either in the language itself or implemented in other projects. So if we want to add a dependency, generally we will import it in the beginning of the file, and we will write it here inside these kind of this import component. So for example, here we have this font or format package. This is similar to the package system.out in Java that allows to print things. So in Go we have this font function that we will be using a lot to write things to the screen, and like to format things, to format strings, to create errors and things like that. So here I have this small description of what is this font. It is basically the package implementing the formatted input output. Guys, if you have any question, just feel free to interrupt me, and I will be every now and then I will. Okay, I will be looking at the chat just to check if you have a question, or you can use the mic at any time. All right. Okay, so now I suppose that you are convinced, since you are still in the session, you are convinced that Go is worth learning. So there is this nice tool called a tour of Go that allows basically to learn all the main features that the language offers. So basically, you can take this at any time, and also it is available online. If you try to Google a tour of Go, it will take you to a similar page where you can learn like the different concepts of Go, and at the same time, like you have in the left side, you have the description of the concept. And on the right side, you can execute examples, and you can modify the code and see it running. All right. So the first thing is the packages and how they are used. So basically here in the import, you will be always importing packages. And by convention, like the name of the package, it is the same name as the last element of the import. For example, here, since format is the last thing, you can use format as the package and call any method that is implemented in this package. In this example, in the second one, here the package will go with the name rand. It will not go with math/rand everywhere, but you can do this as rand, and you see here how this is generating a random integer and printing it to the screen. So we can run this and see that my favorite number, like this, the format is printing this value and concatenating it with the generated random number. Yeah, so there is a way to modify this name if you find yourself with different packages ending with the same name. You can add a name here. For example, if I want to use this package as the name v, for example, I can, if I run it this way, it will throw an error saying that this import is used as v. So this one is not recognized anymore. So I need to do this if I, okay, kill and run again. Okay, now it is running back. Okay, so just for your info, I will not go through all the details of the tour of Go, because I think that you can go through it by yourself in the future or at any time. But I will go through it and just stop for the parts that I think are essential for us going forward. And as usual, if you have any question regarding anything, I will try to answer it at any time. Okay, so this part is also talking about the imports. All right, so I'll just skip this one. All right. Yeah, so this is an important aspect in Go. So exported names and non-exported names. So here we have a package called math that has a method or a constant called pi. We don't really know from here. We don't know if it is. So I will try to run this code and see if this is useful or not. I guess, yeah. So it says that you cannot refer to an exported name math.py. By convention in Go, if you want to have a publicly accessible method or constant or variable, you need to define it with a capital letter. So if this variable or constant was defined as public, it should be with a capital letter. So if we try that, it should work now. So it is showing pi, the value of pi. So this is, as I told you, like generally the convention is keep things private until you need to expose them. And if you want to expose them, capitalize the first letter. So if you have a method called sum, for example, and if you want to use it from other places, just capitalize the S and you will be able to publicly use it. If it is a small s or lowercase s, it will not be visible from other, it will be visible within the same package, but it will not be visible from other packages. Okay, moving forward. All right, so functions in Go. So how to define function is, you will find it if you are using to Java, you will find defining a function here like a little bit inverted. Like in Java, you put the type of the parameter first, and then you put the name of this parameter. In Go, it's the other way around. So for example, here we have a method called add. and it accepts two parameters. The first one is x, and it is an integer, and y is an integer, and it returns an integer as a result. So the name of the function, then the list of parameters, then the return type. So in Go, you can specify many return types. For example, you can come here and say that it returns two integers, for example. And it can work if the function allows it. It doesn't make sense in this example for sure, but if the method allows it, then you can, for example, do this. You can return an error, or you can return many things. So if the function allows that, then you can you can do it. So here we are calling the method with these parameters. So if you run the code, it will just do the sum. And yeah, as any other programming language, you can give one or more parameters. You can call the method without parameters if you want. So this is pretty straightforward. All right. Yeah, so there is a small kind of abbreviation in Go. You will see lots of abbreviations. So if you have like the same, like all the parameters have the same type, you can avoid putting the type for each one of them and just put it in the last one, and it will work in the same way. Yeah. So this is about the multiple results. So here, this method is a swap. So it's gonna swap x, y values. So it will just return two values, and then you can put them into values. I think there are some other languages that have the same functionality as this one. All right. So the named return values, that this is sometimes it can be a little confusing because sometimes you forget that you are using some named return value, and like in this case, you are saying that you will return two values, and you are giving them two names. So these are x and y. So whenever you use the same x and y inside, they will be whenever you return, they will be counted as these values. So just make sure that this named values thing is not really encouraged in the community. So unless you need to use them, to use the returned values, unless you have a compelling reason to do it, then do it. But if you don't, just specify the type. So in this case, I would just say it will return two integers, and I will return x and y. This is like the encouraged way to do it. All right, variables. Okay, so variables. So basically, you can declare your variables using this. There are many ways of declaring variables in Go. One of them is just to put this var outside a function or inside a function, and based on where you place it, it will have some different visibility inside your code. And you can basically use these these variables in the right place. So here they are saying that the var can be at package level or inside a function. So this is the package level. This is the inside the function. Yeah, I'm looking. Okay. All right. So so we can define some new variables with or without like initialization. So for example, here in the previous case, we didn't specify the values of the variables, and in this example, we are doing we are starting two ints. The first one will take 1, so 1 will go to I, and 2 will go to j. Here I'm starting like different types of variables. So this one is a Boolean because it will receive a true. This one will receive a false, and this one will receive a string. So you can initialize them like with different. So you are not limited to one type in the same initialization. Yeah. So the third, and I would say this is the most used way of defining things, is using the semicolon equal. So you don't really need to specify the type of the variable, but the system will automatically detect what type is it, and if there are some ambiguity, it will take the closest. For example, three can go as a float or as an integer, but in this case, since I don't have a .0, for example, it will take it as an integer. Here also we can use that with multiple assignment at the same time. Yep. So the basic types in Go, I think is similar to many others, except probably one minor difference, which is important for many people who are kind of writing code in the system level. So the Boolean is the normal. This is bool, string for strings or expressions and words and things like that. So the difference that I was talking about is the kind of the size of the integer that you want to specify. So if you have a kind of a number, integer or float or double, you can basically specify how many bytes you want to use for this for this number. So for example, if you want to reduce, like optimize your system and want to, and you already know that your variable is going to be always very small, you can specify its size. For example, int 8 will go only on 8 bytes. So there are the flows, there is the rune, bytes, and you can even use complexes with different sizes as well. So you can play with these types here in the playground, but this is not a huge difference with other programming languages. One important part is the zero value. So if you create any variable, so its zero value, if you don't specify anything as initializer, it will take the zero value. And the zero value for an integer is 0, for a Boolean is false, for a string is an empty string. So all of these things, you can execute this code and see what is the zero value for all of these. For the float, it was a 0. For the Boolean is false, and for the string is an empty thing. So this is very important because sometimes it's a little bit confusing for people to use defaults or things like that, because there are no defaults in Golang. You cannot specify that this structure will start always with this default unless the zero value. Type conversions. So you can. So this is talking about the casting from one type to another. So sometimes you cannot go from one. Let's say you cannot go from a string to an integer unless there are some conditions. But you can generally go from an integer to a float into an unsigned integer if the type is kind of was created in the right format, of course. Okay, right. Yeah, this I already mentioned that. Like if you don't specify the type, Go will try to detect the type of your variable. For example, here it will detect that it is an integer. If you yeah, so it is an int. Constants. So yeah, so if you see here, this is similar to the one that we used that was implemented in math. So a constant is declared with this description, like this small kind of const with the name, and you put the value. So there is no semicolon here. It is different from other variables. You cannot say that a constant is like this, because it will throw an error at you. And you can define constants inside the package, like this is in the package level. or inside the function itself. So here we have these constants. Yeah, so this is, you can specify numeric constants. Yeah, I will just skip this one. All right, so this is like the first lesson that introduces like the really the basics of the language. So if you have any questions, please ask them now. Otherwise, I'm moving to the next question, to the next section. Let me take a look at the. Okay, I'm looking at the chat. All right, no questions. All right, I'm moving forward. Okay, so an easy thing about Go is the loops. So if you need to do any iterative work, there is only one way to do it. There is a for loop. And a for loop has 3 parts, and all of them are optional. So so you have, for example, this in this example, we have this for loop, and it has the initialization of a counter, which starts at 0. You don't need to specify the type, as Go will detect it. Then the condition that will be evaluated for every iteration in your loop, and you have a kind of a counter or kind of an incrementation or a post statement that will be executed after every iteration. So so we can get rid of any of these 3 parts. So we can remove the first part, we cannot remove the first part without removing the others because the I will not be known, but we can remove the incrementation, we can remove the condition, or we can remove all of them. So if I do this, basically this is an endless loop. So this is an infinite loop. It will continue to increase things, and after some time it will crash the system for sure. Yeah, so this is a kind of an oversimplification of things. So this is the description of the Go for loop. Yeah, so the initialization is not really. So if you do it this way, if you don't initialize anything and just do this one, it is pretty similar to the while. While your sum is less than 1,000, then you will just continue doing your stuff, and then you'll print everything. Yeah, as I was saying, for is goes while. This is how you write a while. You just use a for loop instead of doing a while, and it will just work. And the last part, this is an infinite loop. So it is a for where you start your code, and it will just continuously loop forever. Conditional statements. So for Golang, if you need a condition, you don't really need the parentheses around the condition, but definitely you need these braces to put your code in. This is similar to this is the same for the if and the else. But anything else is similar to any other language that you use for conditions. Yeah, there is this short version of the if, where you do some kind of an assignment here, and you do the comparison directly. So the condition is basically if v is lower than this limit. But where v is coming from, it is coming from this this expression. So this is some legit code so that you can run. Just make sure that that the v is not visible in any other place other than this loop. So the v is defined in the if statement, and it is not recognized anywhere else. So if I try to use it here, let's say I want to print the v, for example, it should complain. Yeah, it is saying that this is undefined, basically. Yeah, same for the else. You can do an if and an else. Only the usual stuff. Okay, so I will skip the exercise and jump into the next. Switch, many people like to use the switch. So it is basically very close to the if you can use a short statement where you initialize a variable, and based on the value of this variable, you will do some processing. For example, if this value is Darwin, then you will print some statement. If it is Linux, then you will print something different. Otherwise, if it is neither, it will print some third or some default value, and Go will interpret this like in the right order. So it will start with the first one, the second one, and then the third one. So if the first one is valid, the first condition is valid, it will not proceed to check the others. This is how the language is created. So it will try only if it succeeds with one condition, it will not continue to the others. Yep. Yeah. So this is talking about the order that I just mentioned. Switch with no condition. Yeah. So if you don't have any condition, then it is similar to kind of an if-then-else list. So it will just try to execute these things and without using any evaluation in the beginning, except the one that will be defined in the case itself. For example, here, every condition can be different than the other. For example, here we are using t.hour. I can use some different stuff here, and I can use a third condition in the other that doesn't have any link with the previous ones. Yeah, but this form is not generally used a lot by people. I never used it personally. All right, one very important concept, which is the defer. So the defer, as its name says, it is deferring some code. So you use the defer to tell it once the function is done, execute this one. So this is used generally in logging. It is used in like if you are using some parallel programming. Just whenever you open something and you want to close it after you are done, you just put a defer just after opening the thing. For example, if you are opening a writer to write a file and you want to close it after all your execution is done, you can put a defer, close this file after you are done, and it will do it for you. For example, here we will defer printing the world, and we will see that this one will be executed before this one, because this one will be deferred to the end of the execution of the method. Yeah. All right, so stacking differs. So if we have like many differs in the same context, then they will be executed as a last in, first out order. So the last defer will be executed, then the before last, and then going backward to execute all the defers that you have. All right, so this lesson is done. Let's see if we have any questions. Do you guys have any question? Do you guys hear me?
Yes, we can hear you.
Okay, all right. I thought that I was just talking for all the time. Okay, great.
No, we're listening as well.
All right. No questions so far. Then I will move on. So pointers. Pointers, this is a very important topic to talk about, because there are many languages that do not support pointers. But Go is very close to C in using pointers, and shout out to Sitarak, because he taught me how to use pointers and how to optimize them in C. So in Go it is pretty similar to C. So when you use a star like this, a small star before the type, you are saying that this is a pointer. So why you need a pointer? Basically, if you need to pass over the memory address of your variable, just to give it to another function or method and tell it, just don't copy this, but use the original address and put whatever change applied directly to this thing. This is why we use a pointer, to avoid creating more copies and use the original. Just a note here: if you are using Go and want to use a pointer and pass it to some parallel programming code, make sure to kind of protect your pointer, because you will have many Go routines or threads trying to access the same thing, and you can end up with some unexpected value. And if you want to use the pointer, there is a way to kind of derefer the pointer and use the value, which is using the star in the code itself. So we'll see an example really quick here. All right. Okay. So next is the structures. Oh, did I? Okay, I didn't miss anything. Okay. A structure in Go is basically a collection of different fields that you want to put together. So if you have something that you want to describe that has different attributes or different fields, you can put them in one structure. Here,
une petite question pour les pointeurs, et c'est le même principe qu'on sait, c'est-à-dire il a le passage par adresse et le passage par référence.
Yes, exactly. Yes, exactly. So yeah, I didn't go into the details because in the future I will talk about that because we will have the structures, then the methods of the structure, then we will see how we pass the pointers, and how there are different ways when you're writing your code. You can decide either to send the pointer, or what you refer to by the reference to your parameter, or you pass the value of the parameter itself. So the difference is like when you want to when you want the function to make changes to the real object, then you give it the reference. Take the reference, which is the memory address of this object, and make the changes there. So this is the reference parameter. If you basically want to give this parameter without allowing the method or the function to modify its content, then you pass it by value. You pass only the value where the function will get a copy of this parameter, but it will not touch the original one. Does this answer your question, Walid?
Perfect.
Okay. So here we have we can define a new type or a new structure by using this format. So we say this is a type, this is its name, and it is a structure. And then you put together all the attributes. You can list all the attributes that you want, starting with the name, and then putting the type of this value of this field. And as I said in the beginning, like if you want to keep things public, you need to have the first letter of the name of the field should be capital. If it is small, like this, for example, if it is a lowercase name, and if I try to use it from a different package, I will not be able to do so, because this is a protected field. It is a private field. So make sure to make your decision from the beginning based on your design. You need to decide what to put private, what to put public, how to expose things, and the kind of the condition or the rule there. Like if you don't really know, the rule says that keep everything private until you need it. So when you need to make things public, then you can go back and modify that. But if you think that for now in my code, in the status of my code right now, I don't really need to directly access this field from another package, then just keep it private. And you can basically instantiate a new instance of the structure using this this instruction. For example, you put this at the name of the structure, then you put the values. And if you put it this way, so here you are not saying that 1 is going for X and 2 is going for Y. So it will take them in the right order that your definition is written in. Unless if the types are not a good match, then you can do this way. You can say that X will receive 1 and Y will receive 2. So in most of the cases, and this is the way that people implement things. So because generally you end up with structures that have different fields with different types, then you cannot just do it that way. You need to specify that this should go to this field, and this string, for example, should go to this field as well. All right, the struct fields. Okay, so how to access a field? So as I was saying, like if your field is public, then at any time you can use the name of the structure and dot to use the field itself. For example, you can do v.y, for example. You can use it at any time. But if it were private, you will not be able. For example, if we have this way, and if we are writing this method itself, this instruction itself in a different package, this will not work because the X is not visible in that package. All right, pointers to structures. So a structure field can be accessed through a pointer. So if we create a structure, generally we can access its fields using like its pointer. So we can say, for example, here the right thing or the correct thing is to do it this way. So we can put it this way. And but just to it is a convention from the community just to alleviate this process and just choose access directly to this field without using the start annotation. Yeah, this is the literals. This is how to instantiate a structure. So you can either put directly the two values and it will put one in X and two in Y. You can initialize one of them and not the other. You can create the instance without putting anything. In that case, it will, so any missing parameter or any missing field, it will put it as the 0 value. So if I have something like this as well, let's say I have a string here. So if I instantiate my stuff with this, so the C will be put as the 0 value of that type. So for string, 0 value is an empty string. For example, if I have a Boolean here, it will put it as a false to start with if I don't specify anything in the initialization. All right, so I will move a little bit faster. Arrays are kind of very similar to other programming languages. You can put anything inside an array. Even you can put an array inside the array. So here we are starting. You can create an array this way, or you can basically create it in this way. So you can directly say that my array is an array of 6 elements and of 6 integers, and you can put whatever you want inside it. So it's pretty similar to other languages, so I will not lose so much time here. There is an important part, which is slices. So slices here, a slice is a dynamic part of an array. When you create an array, it has a fixed size, but when you create a slice, you can dynamically modify the size. So if you add an element to this slice, automatically you can append an element, and it will automatically create a new copy, or it will add this element and modify automatically the size of the slice. It is very, very close, and people most of the time they can confuse the usage of slices and arrays. But the main difference is that one of them is dynamically sized. So most of the time people use slices instead of arrays. Yeah, so here he says that like slices are like references to arrays, but you always have the way to dynamically modify the size. So here, this is how you can initialize a slice. So you see here that you are not really specifying the size, because its size is really dynamic, and you can in the future you can add as many elements to this slice as you want. So you can look at it as a dynamic array. So this is how I see it. Slices defaults, yeah. So the defaults, as any other defaults in Golang, it will be 0. So if you don't specify an element in an array, in a slice, it will go as a 0 element, or the 0 element of that type. For example, if I have a slice of integers and I don't specify that a particular element, it will be put as 0. If it is a slice of strings, it will be an empty string element. Okay, we can basically specify the length or the capacity of a slice, which is not really, like, specifying the capacity of the slice is not used a lot in the practices. But the length of a slice is kind of you can get the length of the slice, which is pretty useful in many use cases. All right. Okay, so yeah, you can start an empty slice, so it will be init. So this is just a small detail. Let me just skip that. Yeah, so there is this directive that people can use to create two things, basically the slices and the maps. We will see the maps later on, but if you want to create some slice with some particular configuration, you can use the make, and you don't, for example, if you don't have what to put at this time in the slice, but a priori how much, what is the length and the capacity of the slice, you can specify that in a make. So this will create a slice, and you'll specify here the length of 5, for example. Sorry, the capacity of 5 and the length of 0 in this example. And these are really optional. You can create the slice without them. All right. Can contain any type. Yeah, you can put any type in a slice, be it an integer, a simple type, or a composite type, or another slice, if you will. Okay, so how do you append to a slice? It's very easy. You call the append method. This is a known directive in Golang. So you just give it the slice that you want to append to and one or more elements, and it will append them and give back a new slice. So this is sometimes confusing for people coming from other backgrounds, because generally, if you try to append and you give the array or the slice that you have, and you give it a new parameter, you expect that the slice, the new this s, will be automatically the old one plus the new elements that were added. But this is not right. This is why we take the result of this append and put it back to the old slice. So it is like giving this slice and getting the result and putting it in the old one. This is how the append works. Okay, so a different small kind of variation of the for loop that people use really often with maps and slices, which is this one. So if you have a slice or a map, you can do a range. This is there are other languages that implement the same feature, and the result of the call to this range is two things that you can either use or kind of you can use both of them or one of them and ignore the other. So for example, in this case, for this array, we are getting the range of these things. So you will get them element by element. And for each element, you will get its index and its value. So for example, let's say if you don't really need the index, you can omit it. So you can ignore it by having adding an underscore. So in this case, you will be basically using only the value, for example. I'll just remove this. So it will print some dummy stuff. Also, you can replace, and if you want to use only the index and ignore the value, you can also do that. So you can also, I believe you can even do this, and it will work. Yeah, so it works. So all these three variations work. So the range is pretty useful functionality that you can use, and if you used it in other languages, it is very close to that. Yeah. So this is what I was talking about here. So I'm skipping. So this is an exercise that you can take offline. Oh, okay. So the maps are very important here, and they are very useful. Where basically you are mapping two things together and taking one as an index and the other as a value. So for example, here we are creating a map. The map is a kind of a dictionary where you have a key and a value. But the difference here that the key itself, it can be any type. So you can have, if it makes sense to you, you can have the key as an object, as a vertex, for example, and the value as another vertex or as an array of vertices. So this is I think this is different from Java, I believe. Okay. Yeah. So same thing. You can use the make to create your map, which will create. You don't need to specify the size, but if you want to, I think you can specify the size. Otherwise, it's just saying that create a map that has as keys a string and as values a vertex. And after doing that, you cannot go and modify the key or the values. So it will be mapped to a string and a vertex. If you want to have it more kind of flexible, there is a way to use interfaces. So you can say that this is an interface, for example. And an interface, then you can map it to anything, basically. Yeah, so same thing here. How to initiate or to initialize a map. So you can create this map, and basically you are saying that this map is a map of string vertex, and putting the elements directly. So you can put the key. This is a string, and this is the value. This is the key, and this is the value. So I think this is pretty straightforward to set up and use. Okay, the top level type is just a type name. You can omit it from elements of the literal. Yeah, so if you have just any type, for example, here in this case, you have the value is going to be a type, or in this example, a vertex. You can omit the definition, because the previous slide, we needed to put this to say that this is a vertex. But since this is already written in the description, you are specifying that it must be a vertex, then it will automatically try to map this to a real vertex. Why they are adding this description? Because sometimes, as I were saying, if you have this as an interface that can map everything, then here basically you can put anything. So if I have two structures that accept the same thing, it will be ambiguous in the initiation. So you need definitely to specify which type to put in there. But if you have this as a fixed type from the beginning, then you can omit this part. Mutating maps is how to modify an element inside the map. This is the usual business as any other language. If you have a JSON object or a dictionary or a key value thing, you just specify the key and you put whatever you want there. And if you want to read, also you specify the key and it will give you the value. This is not new. Yeah, the part that is very useful is this one. So basically, if you want to check that an element exists, like in the Java world, you can say that you can ask the map, does this element exist or not, and you give it the element. But here, it is pretty similar. You say you try to call the map with this key, and you will receive two values. One is an element that can be nil, so it can be empty, and an OK value. So so this is a Boolean value that you will get that tells you if this element exists or not. So generally, what people do is ask the map, do you have this key? It will answer. Then make a check on the OK before accessing the element that might be an empty thing. And if you try to access it, then you can have some kind of exception. So you need to check first that the element exists using the OK term. This is a Boolean that you can use. OK, so this is an exercise that you can take offline. Function values, yeah. So you can basically you can pass a function to a function. Basically, a function value may be used as a function. Yeah, so you can pass a function as a parameter. This is close to Python, where you can use closures and functions. I will not go into the details of this one. This is Fibonacci closure. Okay, so we are almost done with this. With this lesson. So any questions regarding that? Let me check the chat. Okay. Oh, all right. So I will move on to the methods. So what is a method? It's basically a normal function that has a kind of a receiver. So in other languages like Java, a method is a function that is related to a class or an object. So whenever you want to execute this function or this piece of code, you need to relate it to something which is either the class, so you have a class method, or if you have a specific instance or specific object where you will execute this method on. This is similar. So in Go, a method has a type of a receiver, and this receiver generally is a structure. So you have a structure, and you will kind of add a method that will be used on this structure in particular. For example, here you have a vertex structure, and we are defining a method called abs that will work on the vertex itself. So if you create or instantiate a vertex and you want to have this method applied to it, so it will basically use the values or the fields of this particular instance. So basically, it will be using V as you name it here. So basically, what you are saying here is that this method will work with an instance of the vertex that we will call V in the context of this method. So inside the method, you will not see the whole vertex thing, but you will see it using V as if a parameter or a variable that is passed to. So it will be calling that and using it and returning. So this is to put it as simple, but generally, like the general kind of usage of these things is people will pass this as a reference to or a pointer to your to your structure. This is the most used case. I almost never seen anyone using it without the reference, without the pointer. Yeah, as I was saying, like methods are functions. The only thing is that they have this receiver that they will use, and they can modify their values and use their fields without any complications. All right. Methods continued. Okay, you can declare a method on non-struct types too. Okay, so if you have, yeah, so this is less used. If you have a type that is not a structure, for example, this is a float, you can also define methods for that particular type and it will work, but this is not that used. All right, so this is what I was describing as pointer receivers. Generally, this is the way it is being used. So if you want to define this scale method on a vertex, and you want it basically to modify the values of x and y for this vertex. So basically, you pass a pointer, and the scale method will be using the real. It will not create a copy of the vertex or its fields, but it will be modifying them directly. So the result will show up if you try to print it. So it will show up the real scaled value, not a copy of them. And yeah, as I was saying, like this is the most used thing. Generally, people don't use this way; they use it with the pointer. Pointers and functions. Here we see the this is pretty similar to what we were discussing. Methods and pointer in directions. And this is pretty old stuff. All right, I will skip this one as well. Do you have any questions about the methods and pointers? Yeah, they are saying this. In general, all methods on a given type should have either value or pointer receiver, but not a mixture of both. But generally, people use the pointer version of the methods. This is what I saw so far in the community. I might be wrong though. Okay, yeah, probably one of the important things is interfaces. This is completely different from other languages. The way Go implements interfaces or defines interfaces. So in Go, you can define. So an interface basically is kind of a contract that you define. It is a bunch of methods that you want anybody to implement this interface. He needs to implement these methods. If he doesn't implement these methods, he doesn't qualify as an instance of this interface. So basically, the definition of an interface, it is a type. You put the name and you say this is an interface, and then you specify the list of your methods. And it is a very lightweight signature definition where you put the name of the method and the list of its parameters and the return type. For example, you can say that this is accepting 2 integers in the string, and it returns 2 things. It returns a float and an error, for example. This is a valid signature definition, and it is basically trying to harmonize the implementation of some particular aspect of your code. Yep, interfaces are implemented implicitly, which means that in other languages, if you want to implement an interface, in your structure or in your class, you say that this class implements this interface. And this is pretty clear, and you're naming both things. But in Go, you basically don't say that. You don't say that my class implements this interface or this structure implements this interface, but you just go and do it. So if you implement, for example, for this interface, if you want the structure T to implement I, you just go and implement the methods, all the methods that are described by the interface. This is how you implement an interface. There is no kind of implement thing. You cannot say like implement I, or this doesn't make sense in Go world. You just implement the method and you start to use it. And you see in this example here, we are starting, we are instantiating a structure T with this value hello, and then we are using it as a variable, as an interface, and it will just work because we implemented M. So if I just modify this as M1 and try to call it, then it will just fail, because this assignment itself doesn't count as a correct assignment, because T is not really implementing I, so you cannot assign it. Assign a type that is not in the same world of the interface to this type of interface. So if you need to do that, you need to implement all the methods that are defined by the interface, and this will work this way. Okay, so okay, under the hood, interface values can be thought as a tuple of value and a concrete type. Yeah. So generally, when you instantiate kind of an object or a structure and assign it to an interface, so basically this definition itself, it will save two things: the value, which is the object itself, and the type. Because the real type is not the interface, but the small type or the lower type that is implementing this this interface. Yeah, so you can basically define a nil, like you can instantiate an interface with a nil definition, and then it will call the method with nil. For example, here, if your object, if this T is empty, is not really defined, or if you didn't put anything inside it, you didn't instantiate it, you just defined it and didn't put anything, like here. So you have the interface, and you kind of created an instance of T, but it is still empty. You didn't put anything in it. Then you assign this to the interface and try to call the method. So in other languages, it will yell at you and tell you that this is a null pointer exception, because your object is empty. But in Go, you can implement that and it will work, because you are kind of putting a check here. If it is empty, here you see probably, I think you see the nil for the first time. So nil here is the equivalent of null in Java, which is the empty or the zero value of a structure and an interface. All right, nil interface value. Yeah, so this is about nil interface values. The empty interface. Yeah, there is an empty interface. You can read about that offline. Yeah, so type assertions is done similarly to other languages, where you can cast an object from one object to a particular different, like, interface thing. For example, here, if you have if you define this as an interface from the beginning, you know that it is a string, but you defined it as an interface. You can then transform it or cast it to a real string, and it will just work this way. If you try to cast it to an object that doesn't match the description of this element, like this example here, you are trying to cast hello to a float or to an integer, then like the implementation, like the compilation of your code will not show any error, because the code is valid, because you are using an interface in the end, and like the compilation doesn't know exactly what it is, but when it try to execute the thing, it will panic, like the code will fail. Saying that this doesn't work because this hello is not a float. You can see that, and you can see the panic code. Or all right, type. Yeah, you can move from one type to another, and you can do the casting, and you can play with that offline. I'm trying to go faster. Stringers here is. You can see it if you are familiar with Java and you use the toString method, that like almost everybody is implementing. This is something similar. You can implement a stringer method that will transform your object to a string. So if you print your your structure, it will use that automatically use the string method for you. Okay, this is an exercise. I'll just go. Okay. Errors. So how Golang manages errors. This is one of the kind of most discussed things in the community. Like many people doesn't like this way of handling errors. It is different from how other languages handle exceptions. But people you can get used to it really quick, and it gives you some kind of reflection on how to manage your code and how to be aware of any possible issue that can happen. Because most of the methods that people write, if you take a look at any open source project, like most of the methods, most of them, they return they might return many parameters or many results, and one of them will be an error. So if you call any method, you can expect that it will return something with an error or just an error. And the first thing that you need to do is to check if any error happened. If the error happened, then you need to do some real processing. So in Java, you do the try and then you catch your exceptions. In Go, you make the call to the method that will return an error, and then you will make the check yourself. And you see here in this example here, you will see similar code everywhere in the internet, in the open source community, like making a call to a method. For example, here it is a conversion call. Then it will receive the result, which is the real result of the method, and an error value. And then the first thing to do is to check if an error happened. So if the error is not nil, so if nothing happened and the execution was successful, then you will get a value and the error will be nil. If anything bad happened, you will receive that in an error, and you need to do some particular processing. For example, here we are just doing a format to write out that something bad happened, and we just return. Any questions related to that? Yes, so some people just find it boring, but after some time you feel that this is something really powerful, because it will give you this awareness of checking for every single code that you write that you are handling your exception in the correct way. Okay, some exercises regarding errors. Readers, I will not go into the details of readers, but they are similar to any other language where you can create a reader and you can read bytes out of a file, out of a string, out of stream of data. Is pretty similar. Images, I will not do that. Exercise of images. Okay, next lesson. So the next lesson is about parallelism. So here, like the concurrency mechanism of Go, which is
I'm sorry, can I please ask a question before moving on to the next lesson?
Sure.
Thank you. So actually, first of all, I would like to thank you for the insightful information that you've already given us. It was really clear for me. Thank you very much. And sure. I'd like to ask just one question. It's regarding the DevOps concept, because I don't know if you can at least present us with the concept, or tell us why is it so much used today, and why is it a trend for today, just so we can see where the Go lingo will go, will be insightful, and we will work with it in that context.
Yeah. So thank you for the question, and you are welcome for asking any questions at any time. So basically the Go and the DevOps I don't think there is a kind of direct link between both of them, but I needed any language to use in order to show how we can do DevOps. So Go language, you can do DevOps with any language. But I chose Golang because it is the trendy language that many distributed systems use today, like mainly Kubernetes is using Golang, and Kubernetes is supposed as the distributed system of like the OS of distributed systems. So it's the operating system of distributed systems. Going back to your question about DevOps and how like the history behind DevOps. So previously in a development project, there are different teams doing different roles. And one of these teams is the developer. So a developer will go and write some code to resolve some problem. And then you have another role, which is the ops, which are the operation team, which will be the people that will take this code and put it in a deployment or a real production environment and keep maintaining it. So if anything bad happens to the code, they will try to fix it. If they don't know, they will go back to the developers and ask them for fixes, and they can even bring them in and try to resolve the issue. So we have the developers and we have the operations. So some companies, and mainly Netflix and others, they start to see that this model of separating developers and operations is not working. Because imagine that your operation guy is a new guy. He never used this code. He didn't write the code, and there is a small kind of exception happening somewhere in the code. He doesn't really know how to resolve it. So he needs to take the phone in the middle of the night, call the dev guy and ask him help. Just can you try to resolve that? So it was not really working. So they decided to go as a first iteration to have the developers work, and they want to have some person from the operation to be always with the developers and bring some insights in the operations. This model also didn't work, and then they decided that. So I think they went through different iterations until they reached this DevOps model where the developer himself is the operation guy. So they say that if you write a code, you own it from end to end. Like you write the code, you do the operations, and you do all the needed management to manage your code from writing the code to fixing it to deploying it to monitoring. To monitoring the code. So this is where the DevOps concept came from, and with this concept came like many small practices. I have that in the first slide of this course. Let me open. You can check like the first part of the thing where I put the objectives. So there are the development part. It is part of the DevOps. There is the testing of the code. It is part of the DevOps. Because the DevOps, after all, is trying to have all these, like the management, the lifecycle management of all the of the software, owned by one team. So what does this involve? It involves writing the code, testing the code, building the artifacts of this code, and deploying them and managing them, like with monitoring, with like different strategy of releasing the code. And they want to try like the best out of these technologies to automate everything. So if you can automate anything, then it is they try to do it in the DevOps model. So this is like the overall picture of things. This is why I chose Golang, which is just my favorite language. So it is not kind of a necessary thing for DevOps. But definitely you need a language to write your code. But then there is another step that we will learn is how to write tests, and we will use Golang to write tests for the code, because you need to test your code before deploying it. Then there is the a part of how to containerize the code, which is a part of the deployment itself. There is a new trend of containerizing everything and using Docker and Kubernetes to the deployment, because it will automate many parts, and it will handle like many aspects of the DevOps techniques, like failing your container, restarting it somewhere else, scheduling it. All these kinds are we'll see them in the Docker and Kubernetes part. There is the CI/CD part, which is trying to automate all this process. So whenever you have some code, you just push it to GitHub. Then you will have a pipeline that will run your tests, build your containers, deploy it to your environment. So it is like all the flow from writing the code to the deployment. In the final step, which is more close to the operation part, which is controlling, monitoring your code and seeing when your code is failing or not, what to do if my code fails, how to write the traffic, how to route the traffic, then how to do a canary. I don't know if you are familiar with the term canary or not, but this is how people in production kind of ship new code. They don't just take the old code and put the new code and wait for bad things to happen, but they deploy things in the same environment and give just a small percentage to the canary. How people do dark releases, all of that we will see it in the last section, but this is just the first session is just an initiation to how to write some code. We will write together some code. Next week we will write the tests, and we will continue from there. Does this respond to your question? I believe it was a long answer, but
yeah, totally. Thank you.
All right. Okay, so I will jump directly to the Go routines. So Go routines are one of the main kind of advantages of Golang, because it optimizes the processing really well. So if you are using any parallel programming, just follow Google and all the big companies in deciding to use Go, because they found that it is very well in scaling. If you are running millions of processes, then this is the right language to use, because it allows to use Go routines, which kind of optimizes even further the usage of threads. So what is a Go routine? So for the people who are familiar with threads, like the usage itself is going to be really close to how threads are being initiated, but the scheduler, the Go scheduler, will kind of optimize that for you. So in order to start a new Go routine and run some code in parallel, you can just use the term Go and call your method. For example, here is a simple example. You have a method called say, and you want to call it in parallel. So you will use a Go routine here, call. So it will spin up a Go routine which will run in parallel with the main routine. And also at the same time, you will call this this is not a parallel call, but it's a normal call. So let's see how this goes. So you see that the order of the things is mixed, because this one is really running in parallel. So you cannot really enforce it to be in a specific order, because they are both running in different Go routines, and they are doing what they need to do based on the timing that they are getting from the processor. So any questions about the Go routines? This is a pretty important feature, and also it's pretty easy. You just, in your call to the method, you just put a Go, and it will spin up a new Go routine, and it will work. So channels. A channel is a way for Go routines to talk. So if you have different Go routines and you want them to communicate, or if you want them to return something to the main program, you can use a channel. A channel, I think, is pretty known in other languages as well. But So here you can create a channel and give it to the Go routine, and when and this Go routine can write to the channel, and the value will be visible to other Go routines, and it will be visible to the main to the main function, which is also running in the main thread. So here I'm just running the code. Yeah, normally I'm calling this. So this is a first Go routine that will take basically the first half of the array or the slice, and doing a sum over it, and returning the result to the channel. So it will write the result on the channel. Same thing. We will call in a second Go routine. So with the second part of our slice with the same channel, and then we don't really know which one will come back first. So we don't really know. We will read twice from the channel, but we don't really know which one is writing. If it is the first Go routine or the second Go routine, then we will just print the result, which is showing here these values. All right, I will skip the buffer channels where you can specify the size of the channel and how many elements it will return. So I'm kind of okay. Select, yeah. So you can read about the Go routines offline, because I don't have enough time to cover all of these parts. But this is like really straightforward. You generally spin up a new Go routine, and if you need any kind of communication, you use the channel. This is an user size. You use one or more channels to make them communicate together. All right. Okay. I think this is about it. This is another exercise. Okay. So from here we are done with the tour of Go. So we almost covered, I would say, everything in Go. There are more things that we will see in the course, but let's take it one step at a time. So any questions before I move to our use case? All right, so you can, yeah, please try to take the quiz. I took it and it was correct. So just take the quiz and, okay. So the setup of your Go environment, I hope that everybody got the chance to install Go. But if you didn't, then I invite you to download Go for your particular operating system and set it up in the right way. You will find the description in this page, or you can Google it. This is the same. It's an embedded website, so you can Google it and install Go. And if you have any issues, please feel free to send me a message. So just to let me switch my screen sharing to jump to my terminal. So okay, so after installing Go, you will be able to run this first Hello World Go. Okay, installing extra. Yeah, so I don't want to do that. Okay, so this is our use case. So I want to run this simple use case where we have this kind of shopping cart where we want to be able to create an empty cart, add or remove elements or products to the cart, and at any given time, I want to consult the content or the total cost of the cart. So this is just a pretty simple example that I want to implement and use it like along the way in the other sessions, hopefully for the CI/CD for the tests and CI/CD and containerization as well. So if you are not ready yet with the setup, you can also if you go to this page and you have a link to the GitHub repository. So click on that and you will find yourself in this page. So this page has the needed code to start with. And I try to put different branches. So every week I will be using a different branch. So for this week, I will start with the week 1 initial. It contains some some initial code, but it is not really implementing everything. It is putting like the overall structure of the project, and it is putting just some dummy methods here, and we will try to write this code together. How can I? Okay. All right. So I will modify my screen share. All right. So do you guys see my screen? Okay, so so Sammy saying yes. So let me know if I need to increase the size of my my screen a little further. So generally what I do personally, I started using Go like a couple of years ago, and the dependency management was different than now. So in the past, you need to respect the GitHub structure in order to create your Git project. But today it is not a real constraint. So I will create live shopping cart, for example, directory. So feel free to use your favorite editor to do that. Personally, I will use Vim to do that. So I will create a main.go file. Okay, so with this editor, if you create a main.go, it will initiate it with this value. So basically, I will just write hello Horizon. Okay, all right. All right. So I'm splitting my terminal into two pieces. And for dependency management, Go is using some tool called Go mod. So it is basically referring to Go modules. So you, in your repo, you say just Go mod init, and it will start tracking your dependencies and importing them for you. So it is pretty straightforward. Then I can run my first main.go. So it is saying hello Horizon. All right. So so we need to implement a shopping cart where we will be able to add items, remove items, and get the total cost. So personally, I generally try to put my resources in a folder resource, and I saw that like in the community, this is kind of a pretty useful way to organize things. So if you look at any big project, you will find them defining their resources in a resources folder. All right, so then I will create a file called resources.go. All right, so I will move resources.go inside resources. All right. So now I have this resources. So first thing is to define the package. The package here is called resources. Generally, the package is the same as the folder name, and here I will define a new type called item, for example, or we can call it product. But in GitHub, you will find it called as item. So I will just keep the same. So you find things. Like you find yourself familiar with that. So it is basically a struct, and this struct has different fields. So we saw the fields, they have a name, or let's call it, for example, this is a string. It has a name that is a string. It has a quantity that is an int. We can specify the size of this int. For example, it can be an int32 or something like that. And we have the cost or the price, which is a float. Let's say it is a float 64, for example. So so this is my my item. All right. So then I need to, so first thing I need to be able to create an item. So if I go here, I can do resources dot item and put an ID, for example. My ID is, let's see, this is gonna be a vegetable, and its name, we can put a name, let's say potato, and we can put the price or the quantity, let's say 2, and we can put the price. All right, and this can be 1.5 since it is a float. All right, so so here, so if your editor is configured correctly, it will start showing some errors if you have anything that that Go doesn't like. For example, here it is saying that this item is created but not used. So I will just use, I will call it item, or I will call it just potato is equal to this guy. And we can either write anything. We can use it in format.printf. And we can say that this is going to be the value. So here I'm putting this %-v. This is a particular directive to say the value of this thing. And there is the \n to return to the line. Okay. All right. So now we can run. It will show us here the potato. Okay, so this is not that useful yet. So I will create a folder called cart. All right, then I will create a file called cart.go. Okay, so I'll just create it directly inside cart. All right, so now let's start implementing this this cart really quick. So our package is called cart, and I would like to just to implement things in the right way. I would like to use to define an interface. So I will just define a type called cart interface. So if you have a better name, please go ahead and just use it. So I would say that this is an interface, and I have this should respect the description. So we should be able to add an item. So if we want to add an item, so we should pass an item. And as kind of a good practice is to return an error if anything bad happens. I should be able to delete or remove an item. And I should send, for example, the item ID, which is a string, and the quantity that is an integer. And same thing here, I should be, so I will not implement total cost. I will not implement all the methods. We will get started together with 1 or 2, and then I will give you a homework to finish the others. So total cost is a method that doesn't have anything as a parameter, but it will return a float, let's say 64, and an error if anything bad happens. So now we have our interface ready, and we are ready to start implementing it. So the first thing is to create a cart. What a cart will look like in this world. So I will just keep it as just note that I use it a small, like a lowercase letter here, so it's not going to be visible outside of this package. And this is to force people only to use the interface that I'm defining. Please feel free to interrupt me at any point and ask your questions. So what defines this cart? I would say it has only items. So I will use items, and it is defined as a map of string. So it's going to be a map of string and resources.item. So this is my cart. Basically, it has a map of items. That's it. All right. So I will create a method that will return. Since my cart is a private structure, so I need to define a way to create an instance out of it. So I will call it a new cart. It will not get anything, but it will return. Mind here that I will return a cart interface. This is to force the usage of the interface. So here I am saying that a new cart will return an interface, like an instance of the interface. So I will return something. So I need to return this cart. So I need to instantiate a cart. So how to instantiate this cart is basically creating the cart with its field called here items. I will just put there a new map of as defined there and resources dot item, and I will just put the items like this. So now the system is angry at me because it is expecting a new line or right. Okay, so what I'm missing here. All right, so okay, yeah. All right. So now it is yelling at some different thing, which is saying that you cannot use the cart literal as type cart interface, which is legit because the cart is not implementing these methods. Just to make this error go away, I can implement a function called add item, and that will take as a parameter. I need to respect basically the signature of my methods. So basically, I will just return nil. But I need to make sure that I use the receiver as the cart. So it is a receiver of type cart. So now I'm saying that cart is implementing the add item function. So I will copy over this. Okay, v. So just to implement these methods. So add item, remove item. So remove item gets a string and an int, and I need to give names if I want to use them. I need to I will call it item here, and the remove item I will call it ID, for example, and this is quantity, and all of them they return nil. So this is okay. So let me check. Okay, total cost now is missing. So I will implement total cost here, and for total cost I don't get any parameters in, but I return back a float, say 64, and an error. So I need to modify just the return here to return, for example, a 0 and a nil. So now I don't have any issues, but I can initiate my my cart. I can, just to make sure that that it is like doing something, I will add some here. Let's say I will return an error, just saying that this is not implemented. Okay, so now I can go back to my main. All right, so so I can create my cart here equal it is coming from the package cart because I defined the package as cart. So I will call the method new cart with nothing, and I will get a cart So you see that automatically Go will, if you have done the right setup for your editor, Go will import for you. So if you import anything, it will try its best. If there is no ambiguity, it will just import the thing for you. So I'm trying to go really fast here because we don't have enough time to go into all the details, but feel free to interrupt me. So I'm creating this cart. Now I can start using it. So this is so if you are not using a variable, Go will not like it, because if you define something, you need to use it. So I will add an item, which is my potato. And as I said before, every time I call a method that might return an error, I need to check if the error happened or not. So if error not equal, so you will see this part of the code repeated very, very often. I will just print it out, or print line. All right, so I'm creating a cart, I'm adding an item, but I should see that the method is not implemented. So this is what we were saying. So now we can go ahead and implement our cart. So if I'm receiving an item to add to my cart, what should I do? So there are some best practices that people are doing in implementing the code. So the first thing is to log when you are entering or exiting any code. So you say that here you are entering the add item function, so you can follow up or trace your code, and then you defer writing same thing, logging that you are exiting. So you will see me using this really often to trace the code and trying to find any issue with my code. So here I'm entering my code and I'm getting a query. So the first thing that I need to do is to go to this item and try to add it. So what are the things that I need to check? So first, if it is the first time that I have this item, there is a different way to handle it, and if it is already existing in my cart, I need a different way to do it. Since I am using a map, so I can directly jump in and say, ask the map, since it has these items, I can tell it, do you have this item ID? So item.id. So the map will return two things. So it will return an existent item and an OK. So first thing I need to check if the item exists. So if OK or if not OK, this means that the item doesn't exist. Else, I will do something different. So if the item doesn't exist, all what I need to do is to do my adding, like c dot items of this guy equal my item. So this way I'm just adding my my element to the list of items. I can add a logging message there, or just put the element there and go ahead. So else, if the element already exists, so what should I do? So the only thing is I need to this existent element or existent item dot quantity. So I need only to modify the quantity of this guy equal its previous quantity. Item dot quantity plus the new, which is the request dot quantity. All right, so this way, and that's about it. So I need to check if this item exists. I will just add to the existing item, and then I will just return nil. So here, instead of returning an error, I will just return nil. So this is our first function. So we can try it since we are already adding. The only thing that we need is we can, instead of printing the element itself, we can go ahead here and print the my cart. And here I will just print my cart. All right. Okay, so we see that we are able to add an element to the cart. So this is like the initial part of the implementation. And since we are running out of time, I will not like continue to do that. But you have this initial code to start with, and I will ask you for as homework to implement the remove item. Basically, it's gonna check if this item exists or not, and it will remove it from the map. There is a feature that like a call that allows to remove elements from a map, which is the call to delete. So you call delete and you give it the map, and you give it the key of this element, which will allow you to implement this method. And think of a way of implementing the total cost functionality that will return the total amount of the cost of all the cart with the different elements that the items that it has. This is about it for this week. So I will just stop the recording, and I will ask you if you have any further questions.
Mohamed, est-ce qu'il y a un éditeur